Ignition sequence start. 6, 5, 4, 3, 2, 1.
Law of thermodynamics, established with ample experimental evidence, governs the change in a closed system over time. It states that within such systems, the degree of disorder, also known as the entropy, will always increase. Another way to state the second law is that the entropy of the universe increases in the course of any spontaneous change. Of course, in thermodynamics, the universe is comprised of the system and its surroundings. Because of the second law, a gas will expand to fill the void. Gas atoms do not spontaneously gather in a corner of a room. The always increasing disorder occurs because of the tiny amounts of heat which is slowly exchanged with the surroundings. We can represent this tiny amount of heat as delta Q, where Q represents heat. The equation for the second law states that in a closed system, the change in the entropy represented by ds must always be greater than the tiny amount of heat divided by the temperature at which the transfer of heat is taking place. This applies to all processes which are considered irreversible. In fact, this applies to all real processes, since fully reversible processes are strictly theoretical in nature.
Okay, as you can see, we're up in the mountains. We're 10,000 feet above sea level, and that means the air pressure is very low. So if you look at this packet of crisps, it's really inflated and feels a bit like a balloon. And that's because although there's the same amount of air inside the crisps, there's less air outside because we're so high up. So there's nothing pushing against the packet. So the packet's expanding, and when we get down to sea level, we should see a change in the crisps. That is, of course, unless it's burst, sending crisps all over us. So hopefully I'll be able to show you the crisps in a little while when we get down to the bottom. Here we are down the bottom of the mountain, and we've got the same packet of crisps, unopened, and you can see that far less air inside, although actually the same amount of air inside, but because the air pressure is much higher down here, it's actually pushing against the packet. So you've got there good demonstration of air pressure using crisps. I'm going to taste them to see if they're okay. Lovely.